Excuse me, ma'am.
Yeah?
The class before the last class, the recorded class section is saying, it was saying you don't have permission to access the file.
Yes, I'm going to upload it again on YouTube. So I was getting the text, the message. I'll upload it again on YouTube and put another link. It's fine.
On YouTube or on the LMS?
I'll put it on the LMS. Can you mute yourselves?
Okay, ma'am.
So I'm going to put it, I'm going to re-upload it and put it on the LMS so that you can view it. So today we'll just go over to nomenclature of coordination compounds. Luckily, we've been able to know how to calculate oxidation state, coordination number, because and how to name ligands too, because if it's chloro, bromo, and all that, if it's water, it's aqua. So since we have done all that, we can then go over to nomenclature of coordination compound, because here we are going to learn how to name our coordination compounds. And we are going to look at some of the rules before we now look at some coordination compounds and we try to name them together. After which I'm going to give you some assignment that you are going to practice. So what are some of the rules? The rules employed in naming coordination compounds. The first one is that cations are named first before anions. Cations are named first before anions. And if you have within the coordination complex, you first of all name the ligands before the metal ion. You name the ligands before the metal ion. And in naming the ligands, we also take into cognizance the first letter of the ligand. So we list the ligands in alphabetical order, regardless of the charge on the ligand. That is, regardless if it's a neutral ligand or if it's an anionic ligand. So in listing the ligands, we list alphabetically, irrespective of neutral or charged ligand. Then the number of a particular ligand in a complex is indicated by prefix. That is, depending on the number of ligands you have. If you have one, then it's mono. Most times, if it's mono, we don't actually add that mono. But once it's more than one, you can add di, tri, tetra, penta, and all that. So with that, we'll be able to know the number of ligands that is actually coordinated. Then another rule is for complicated ligands. What do we mean by complicated ligands? That is polydentate ligands. So for polydentate ligand, because they are many, they are large, we actually use the words bis, not tri, or tetra, or bi, or di. So we use bis. Bis is for 2. Tris is for 3. Tetrakis is for 4, and so on. So that is when you have polydentate ligand, like your ethylene diamine, like your EDTA, like your polyphosphate. Those are polydentate, or what we call complicated ligands. Then, aside naming the ligand, because these ligands the complex we have talked about are the ones in brackets. You can also be asked to write the formula. You can be given the name of the complex and you're asked to write the formula. If you're writing the formula, the metal is listed first. So invariably, the way we name is different from the way we write the complex. The complex, in writing the complex, the metal usually comes first. But in naming, we start naming starting from the ligand. So in writing the formula, the metal is listed first. But in naming, you start naming from the ligand. Then the names of anionic ligands end in the letter O. Anionic ligands like your chloride, so it becomes chloro. Like your bromide, it becomes bromo. Like your hydroxide, it becomes hydroxo. So the anionic ligand, that is ligands that are negatively charged ligands, actually end with the name O. While neutral ligands will just bear the name of the molecule. If it's water, of course, we know this aqua. If it's NH3, which is your ammonia, then we know this amine. Those are neutral ligands. So we have special names, which we looked at the last lecture. That was why I took time to look at that last lecture. And I've already posted the slide and the video. I hope we have gone through it to be able to know how to name. So we have special names to water. Water is aqua. NH3, which is your ammonia, is amine. Please check the spelling. It's double M. Students always make the mistake of writing one M. If you write one M, I will mark it wrong. One M is amine. That is your NH2. It's different from your NH3. So your NH3 is your amine. Your NH2 is your amine. It's the same. You see, it's the same sound, but the spellings are different. So if you write AMINE, I will assume that is NH2 you're talking about. Another name for the NH2 is your amido. So you can call it your amine, you can call it amido. Your CO is your carbonyl, and they are all neutral ligands. So always know your neutral ligand, because if you know your neutral ligand, it will help you to calculate the oxidation number, because for the neutral ligand, the oxidation number is 0. While for the anionic ligand, the oxidation number will depend on the charge. So for anionic ligands like your chloro, your bromo, your cyana, your hydroxyl, you see these ones are ending with O, 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 O. So and most of them, their oxidation state is usually 1, but for your CO3 and your oxalato is a 2-. So know the charge and know the oxidation number. So if the complex is an anion, its name ends in 8. What do you mean by 8 if it's an anion? That is, if the complex is negatively charged, that makes it an anionic complex. So it's going to end with 8. What do you mean by 8? Like your copper will now be your cuprate. Your copper will now be your cuprate if the metal is copper and it's an anionic ligand. So it's going to, if it's copper, it's going to be your cuprate. If it's your platinum, it's going to be your platinate. If it's your cobalt, it's going to be your cobaltate. If it's iron, it's going to be ferrate. So that is what we mean by it ends in 8. So your cuprate, your platinate, your zincate, your ferrate, your nickelate, your plumbate, if it's lead. So that is what we mean by it will end in 8. Then the oxidation number of the metal is given in parentheses. In parentheses, that is means that is in a bracket, and it's in your Roman numerals. It's in your Roman numerals. That is how you write the oxidation number. So copper 2, your copper, which is your Cu, will now be in a parenthesis in bracket 2, and the 2 is in a Roman numeral. That is II in capital letter. Then we also have bridging ligands. If you have a complex that has a bridging ligand, we are going to see each of them. I have an example for each of them, which we are going to look at. So if you have your bridging ligands, you usually use the prefix mu. Mu will tell you that a ligand is bridging 2 metal centers. And for every complex you write, please always enclose within a square bracket, whether it is charged or not. Some people, when it's not charged, they just leave it that way. It is wrong. Always put it in bracket form. So we are going to look at some examples. So you look at this example, you see, it doesn't have any charge, but it's also in square brackets. So always make sure all the complexes are in square brackets. That is. So for this one now, we said we normally, in naming, first of all, you name the ligand first. No matter that in writing, you start writing with the metal, but in naming, we start naming with the ligand. So for this, the ligand has, the prefix is how many here? 5. So that is penta. And your amine is A, your chloro is C. So your amine will come before your chloro, because we say we are going to name the ligands alphabetically. So we have penta, amine, chloro, cobalt, 3 chloride, because the chloride is outside. So the word is going to end with chloride. If the 3 chloride atoms were inside, it would have ended with cobalt 3. But because we have a chloride ion outside, it's going to end with chloride. So you have penta, amine, chloro. You cannot say mono. It's 1 chloro inside. So chloro, cobalt 3 chloride. How did you know that your cobalt is the oxidation state is +3? So do we know that? Can you unmute yourself? Just if you know, unmute yourself. Do you know how we got it as cobalt 3?
No.
No, ma.
Yes,
No,
ma.
ma.
No.
No, ma.
Because the oxidation state don't go by the.
No, ma.
Amine is neutral.
Amine is neutral. Your chloride is -1. The one inside minus another -2. Isn't it equals to 0? Isn't it?
Yes, yes.
So we have,
The cobalt, the oxidation state of cobalt is +3.
+3. Thank you. It becomes 3. So are we clear? Are we okay with that?
Yes, ma'am.
Good. So if you can unmute if you can keep quiet, as I'm talking, we'll be interacting. But when you are making noise, I will mute you, so that we can have an interactive class. Although very soon we are going to come to class. How many people? How many are you?
We are 65.
107 chemistry.
107.
107 chemistry.
107. How many are you in education?
115.
115. So that is
120.
Huh?
115, ma.
115. So that means together we have 222 students, isn't it?
Yes, ma'am.
107 plus 115. So it's likely we'll come to class.
Thank
Okay,
you,
ma.
But I will discuss with the HOD to see if maybe by next, I don't know if for next week, but maybe Wednesday we might still have online, but by Thursday we should be able to come to class. So I have to discuss with HOD. Is that okay? Okay, thank you.
Yes, ma'am.
Those people talking, if you know your place is noisy, mute yourself. So for the second one, of course, your A will come before your sulfate. So you will still have tetra, which is 4, tetraamine, copper, 2 sulfate. Do you know, because this is neutral, isn't it? And
yes.
This is -2. So you have X plus 0 minus 2 is equals to 0, isn't it? So
Yes,
your X will now be +2 when the 2 goes to the other side. So that is how we got it as copper 2. For this, we have your amine is 5, pentaamine, chloro, cobalt, 3 ion. Why is it not cobalt 3 ion?
Chlorine is minus.
Because it is an ion and we have +2.
Because it is charged.
Yes.
Because it has a charge. So once it has, you see this one has a charge, it also ends in ion. So once it has a charge, it must end with ion to show that it's an ionic complex. So that show that the complex is ionic. So we have pentaamine, chloro, cobalt, 3 ion. So we have X, we call this our X, which X plus 0 minus 1 is equals to 2, isn't it?
Yes.
This time around is going to be equals to 2. Are we following?
Yes,
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So it's not going to be X minus 1 is equals to 2. X is equals to 2 plus 1, isn't it? So that is how we got 3. So please learn how to calculate oxidation state of your complex. So for this now, it's also going to be an ion, isn't it?
Yes, ma'am.
It's ending in ion. So we have A, which is your amine. A will come before aqua. Both amine and what aqua is AA, isn't it? But your M will come before Q, isn't it?
Yes.
So we have diamine, diaqua, dicyano, ion 3 ion.
Ion 3 ion, yes.
Good. Now, if this sign here was negative, if it was negative, What is going to be the name of this complex?
Diamine, diaqua, cyanoferrate 3.
Good. So it's not going to be ferrate, isn't it?
Yes, ma'am.
Because
Yes,
that's what I want. That's what I want you to get. Good. So you see, this is an anionic. Again, aside this being negative, if the only ligand in that complex is anionic, it also becomes an anionic complex. So there are two scenarios where you can have an anionic complex, isn't it? If the complex is negatively charged, or if all the ligands that are in that complex are anionic ligands. So that will also give us the change in the name of the metal.
We don't understand that part, ma.
This one here, you see that is ferrate 2. Did you get that? Because this ligand is anionic ligand. Are we together?
Yes, ma'am.
Yes,
Together. This is an anionic ligand. So this complex is an ionic complex. So in naming this one, that is why. So we are going this metal, you are going to name starting with the metal. So once you have the alkaline or alkaline earth metals outside the brackets, these are transition metals, mind you. So this carries the name of the complex. But if you have alkaline or alkaline earth metals outside the bracket, that is among the complex, the metal comes first. I think that was, there was a place we had that.
Yes, yes.
Good. So where you name the metal first.
But it's not part of it.
He said in naming complexes, cations are named before anions. It's part of it.
Part of it.
Because this is your cations are named before the anion. So that is why your potassium is coming first. Your potassium is coming first. So you have potassium hexacyanoferrate 2. So 2, this is your 4 minus 6. That is how we got iron to be in oxidation state of 2. So it's going to be, this is going to be 4, 0 minus 6 is equals to 0, isn't it?
Yes.
So you have,
So
this is x. So you have minus 2. X minus 2 is equals to 0. So your x, your iron will not be 2. That is how we got our iron in oxidation state of 2. 6 minus 4. So for this also, 4 minus 2 is going to be x minus 4 is equals to minus 2, isn't it?
Yes.
So x is equals to minus 2 plus 4. Are we together?
No, man, the number 5.
Number 5.
Yeah, like
That's not that number 5.
About that bracket, that parenthesis with just 2 like that.
It's 2 now. What does you want? Yes, now that's all. Ferrate 2. That's all. What do you want to add? It's not an ion. It does not have a charge. And there's no ligand outside.
Okay, ma'am.
I'm listening.
I'm sorry, ma'am. You said it's an anionic complex. So
This is an anionic complex. Because this ligand is an anionic ligand. And there's no neutral ligand here. This is anionic ligand. This is a neutral ligand. So it's not, do you understand?
Yes, ma'am. Yes, ma'am.
Good. This one too is a neutral ligand. This is an anionic ligand. Do you understand? But right here and here is only anionic ligand. There's no neutral ligand. So that is why it will end with ferrate or cobaltate. Are we together?
Yes, ma'am.
So if there was a neutral ligand here now,
question.
Okay.
Sorry, based on about 4 questions. Sorry,
Okay.
If we are if we have to find the coordination number, like the number of the complex that is attached to ion.
The ligand,
since we have different.
It's 6 now. 2, 2, 2 is 6 now. Coordination number is 6.
So they all be attached to the ion.
Yes, now 6 of them will be attached to the ion.
All right, ma.
But for this one, the coordination number is going to
still
be
on
6.
number 5.
Okay.
Okay, ma.
That's cyano. Like, is an anion now, Abi?
Yes, that is cyano. And that is why the ion is answering ferrate. It's not ion. It would have been ion 3, isn't it? But because it's an anionic complex, that is why we are using the name ferrate.
And so it means, like you said, that if we have an alkaline earth metal or an earth metal before that, before the bracket, that will always limit it.
If you have sodium, potassium, whatever you have here before the bracket, it will always come first. That is why we said we run it there. Now that is the first one, that in naming complexes, cations are named first before anions.
Oh, okay, ma. Okay,
yes, thank you, dear. So for this one, it's also an anionic complex. So that is why the name cobalt is now changing to cobaltate, 2 ion, because it has a charge. So that is why the ion is coming at the end. Can we move on?
Yes, ma.
Good. So now, this is a bridging ligand. You know, we talked about bridging ligand, where a ligand can bridge the 2 metal centers. I had a lecture. So this is a ligand. What is the name of this ligand?
Amine.
Amine.
Spell the amine.
A-M-I-N-E.
A-M-I-N-E. Or what? Or what?
Amino.
Amido. So you better use amido so that in case so that you don't make a mistake in spelling. Instead of writing 1 M, you go and write double M. So you can use amido. So the amido and what is this one called?
Nitro.
What is this one called?
Nitro.
This one is called what?
Nitro.
This one is called what?
Nitrito.
Nitrito. Good. I specifically tried to so this is a bridging ligand. So it's bridging 2 cobalt complexes, and each of the cobalt has your ammonia, your amine ligand. So how do we name? Of course, we have to start with the A, isn't it? So this is 4 and this is 4. That is 8, isn't it?
Yes, ma'am.
Octa-amine, that is 8 amine. Mu means is bridging. And what is bridging? Amido. Mu amido, mu nitro di cobalt 3 ion, because it has a charge. So whether it has a positive charge or a negative charge, you must put that word ion. That means it's a charged complex. So how did we get 3? Do we know how we got 3?
No,
everything. No, calculate, everybody. Calculate and tell me how we got it as 3.
The nitro is -1.
Thank you.
The ammonia there are all neutral.
Thank you. So 0, 0.
So 0,
amido.
0.
What about 0. Amido? Amido is -1.
Amido is all, yes.
Good.
Amido was listed among the neutral ligands now.
Oh, sorry. I'll have to. It's
Amido is also neutral.
It's
so
neutral. No, it's not.
Minus.
No, amido is not neutral. Sorry. Amido is -1.
Okay.
Amido is -1. NH2. NH2 is not neutral.
Ma, so if it is like that, it won't be balanced. We'll be having.
Yeah, it won't be 3 any longer.
We'll be having 2.
So calculate now. Hello. Can we hold on and let's do the calculation? Your cobalt is how many? 2x, isn't it?
Yes, ma'am.
Are we together? Because it's 2 cobalt we have now. So we have to get the coordination number for each of the cobalt. So you have 2x, which represent our 2 cobalt, minus 1 is equals to 4. Are we together?
Yes, ma'am.
Because your
Yes,
NH3 and NH3 is neutral. So you have 2x minus 2 is equals to 4. 2x is equals to 4 plus 2, which is equals to 6. So 2x is equals to 6 divided by 2, which is how many?
So
3.
X is equal to 3.
That is 3.
3.
So are we okay?
No, ma'am,
Yes,
please, I didn't
ma'am.
get that, ma'am.
No, ma.
Yes, ma'am.
Okay.
So where are you lost?
Because like you mentioned something of alphabetical order, like when we are naming.
We named amine now, we named amido, then before nitro. So which other order do you need?
Now, what is the oxidation number of the INO2? The nitro.
Minus 1.
Minus 1. Okay, the NH.
Three, ma'am.
Huh?
The NO2. The NO2.
It's minus
NH
1 now.
NH2 is minus 1.
Minus 1. NH2 is minus 1.
Okay, ma'am.
Okay, ma'am.
Huh?
So does it mean
Another question.
we have to name the ligands before the bridging ligand, because the amido should come before the amine if reasoned alphabetically. So does it mean the bridging ligand would always come after we name the
Because it's bridging, yes, because it's bridging. So you name the ligands before this one is just a bridging, it's bridging. You cannot start naming with mu.
Oh, so my means irrespective of alphabetical order, the bridging should always come after the ligand itself.
The mu is only showing that yes, it will always come before the mu. It will come before. You cannot start naming with mu amido, mu nitro. Yes.
Okay, ma'am.
Ma, looking at
Yes.
the bridging ligand now, how are we going to get the coordination number?
Coordination
Because
number
we
for
have
which one?
two metals there.
That is how we got it
For
now.
that,
Instead of
amine, mu, amido.
It's dicobalt now. 3. How you are going to get what?
Now.
Huh?
Coordination number. The coordination number.
It's 3 now.
Because each cobalt is attached to
That is why we did 2x. We did not do x. 2x is standing for your 2 cobalt.
No, my means coordination number, not oxidation number.
This one now, this cobalt is 1, 2, 1, 4. That is 6 now.
Oh,
Ma, as in
so my
coordination, not oxidation. Coordination number.
Yes, my
Coordination number is 6 now for each of the cobalts.
Coordination number should be 10, I think.
For each of the cobalts.
6.
So it's 12 now. Then it's 12 for everything.
For each.
I didn't get you. What are you talking about?
Understood. For each of the cobalts, it's 6.
It's 6.
Okay, ma.
For the whole complex
Ma,
is 12.
Okay, I've understood now.
For each cobalt, this is 4, 5, 6. This is 4, 5, 6. So for the whole complex, we have 12. But for each cobalt is 6. Any other problem? So for this
Understood,
now.
ma.
So for this, what is the oxidation state of your cobalt? Everybody. Because the name is the same. The only different, the name is the same, but I want to know if you understood.
What is EN?
That's 2.
It's
Ethylene
diamine. It's a neutral ligand.
That's 2.
Plus 2.
What is the oxidation state here? So what is the name of this? What is the name of this complex?
Is it plus 2? I don't think it's plus 2 because there's still 4 after now.
-2.
Wrong.
Should be -2.
Wrong. It is wrong.
It's equal to 6.
One.
It's wrong.
Is it
What is the-
-2?
Plus 2.
It's wrong.
Plus 6.
Plus
Plus
3.
6.
It's wrong.
-2.
Plus
Let's
6.
do it. Let's do it.
-1.
It's correct.
Plus 3 years. Plus 3 years.
So let's do. So listen. It's going to be listen now. Listen. So it's going to be 2x, isn't it? That is 2x is standing for your cobalt, 2 cobalt, isn't it?
Yes,
Your
ma'am.
F is -1. Your OH is -1. -1 -1 -4. Now chloride is 4. Now chloride is 1. And you have 4 of it, -4 is equals to 0, isn't it? There is no charge. So the whole complex is equals to 0. Are we together?
Yes, ma'am.
So it's going to be 2x -2 -4 is equals to 0. So 2x -6 is equals to 0. So 2x is equals to 6, isn't it? X is equals to the same 6/2. Are we together?
Yes, ma'am.
So it's also 3. So what is going to be the name now? Name it. Just one person that knows how to name. I name this complex.
Tetra.
Okay.
Midnight.
Only one person. Tetra.
Tetraamine
Bis.
ethylene.
Bis. It's not a. This is it's a polydentate ligand.
Okay.
You're saying
Oh my.
Continue.
Bis ethylene diamine. Then that sign, that U sign.
Mu.
Mu hydroxo
Good.
nitro.
No, now mu again now.
Okay, new again.
Mu.
Nitro dicobalt 3 chloride.
Correct. Clap for him.
Ma,
Yes.
how about the chlorine outside?
That's why he said chloride. Now it ended with chloride.
Okay.
And that was why I said he got it. He ended with chloride.
Okay, ma.
So this one.
No, excuse me, ma. So it means irrespective of the number of chlorides here, it's just the chloride.
Is the chloride? No. The number of chloride will help us to know the oxidation state of the cobalt.
But if it's like no matter the number, it will just be chloride when you.
It will just be, even if it's one chloride. If this is only one, if this is 2, 3, 4, 5, 6, 7, it will just end with chloride.
Okay, ma.
Good.
Okay, ma.
So this one now is the same. The only thing is that this name will now be mu nitrito, isn't it?
Yes, ma'am.
Yeah, the same. The only difference is instead of nitro, you are going to have it as mu nitrito dicobalt 3 chloride.
Ma, why is that? Why is the ethylene please, ma?
Because it's a complicated or what we call polydentate ligand. If it's 2 is bis, if it's 3 is tris, if it's 4 is tetrakis. It's among the rules that we gave.
Yes.
If it's NH3, NH2, bracket 2, those ones are di and tri. Do you understand? But because it's polydentate, it's a complicated ligand, we will now use bis to separate it from the normal ligand, the monodentate ligand. Do you understand? Once we see bis,
yes,
we know that once we see bis, tris, tetrakis, we know that it's a polydentate ligand that you are talking about. But when we see di, tri, we know that it's the normal, your monoligand. Diaqua, diamine, dicarbonyl, do you understand? We know that it's the normal monodentate ligand. But once we start to see bis, tris, we know that it's a polydentate or complicated ligand. Are we together?
Ma, please.
Sorry, ma.
Excuse me, ma, please. Before
Sorry, ma.
we,
For
when
the
this is other person talking.
Who is talking now?
Ma, when we
Yeah.
are naming our ligand,
Yes.
after the tetraamine, is there going
Yes.
to be is there a mil before the bis ethylene diamine, or is just going to be tetraamine bis ethylene diamine, or is there a mil in between both of them?
If there's a what?
Is there a bridging, that mil stuff?
No. Now you only get bridging when you want to use hydroxyl. Mu hydroxyl, mu nitro.
Okay.
So your tetraamine bis ethylene diamine is one word, no space. Caskia is one word. You see, for this one, it's one word, isn't it? Octaamine, mu. You only have a space before the aeon. So for this one, you have a space before the chloride.
I guess what she's asking is, in naming that polydentate ligand, is there going to be a meal like that as a bridging ligand? Is there going to be a meal?
Look at the name. Look at it. I just wanted you to try your hands on it. Tetraamine bis ethylene diamine mu hydroxyl mu nitro dicobalt 3 chloride. Does that make sense?
Yes, ma'am.
Yeah.
For our polydentate ligand, we don't need to put. Okay.
Excuse me, ma'am.
Yeah.
Please, I want to ask a question
Okay.
concerning the example before these polydentate ligands.
Okay.
Sorry, my network locked me out.
Okay.
When you were
Sorry.
deriving the oxidation number of the cobalt, you said the amido is not a neutral ligand. That means we are supposed to consider it to be -1. So
it's
that would be
-1 now.
-1.
-1.
Nitro is also -1.
Yes. And this
So
that is
that's
-2 is equals to 4.
Okay.
Because it's equals to 4. Then, so -2 going to the other side will come +2, isn't it? 4 + 2.
Yes, ma'am. That's
so 6 divided by 2.
Yeah,
you got it.
Thank you,
okay. Okay,
Thank
dear.
you,
Okay. So these are some examples. So I said, name the following coordination compounds. So can we name? Although it's going to, I want you to do that as because that's the end of the lecture. So you are going to do this as, you have to practice on this.
Ma, I have a question.
Okay.
That means it will form a bridge, right?
No, it's not forming a bridge.
This number 3.
It's only telling us that this the ligand is arranged in a trans form. Yes.
Okay.
But here you are just naming. You are not even drawing it.
Okay, man.
So can somebody name this one for us, since he has talked about the trans? Can you name it for us? You will start with trans now.
Yes, trans.
Platinum.
Tetraamine. Chloro, dichloro. Dichloro. Platinum.
Okay.
Platinum 4 ion.
Good, correct.
Sorry, ma, but you said you are going to name metal first.
Hey, what did I say you will name metal? Somebody should tell me.
No, she said when it's outside the bracket.
So if it's this one, like this one now, this one will start with sodium, isn't it?
Yes,
this one will start with potassium, isn't it? This one will start with sodium. For this one, it's not a tetrasodium. Oh. Please, it's not going to be tetrasodium. This is not that it's potassium, Abby. We just started with potassium. So for this one, you're going to start with sodium. For this one, you're going to start with sodium, potassium. This one, you are not starting with a platinum now. Abba.
Okay, ma.
Hello, ma.
in number 6, where we have the NOS.
This is what?
Sodium. A bit sulfur.
This is what? Go and don't ask me, I will not answer any question again. Go and read. Go and go and practice your hands on it. You don't want to do any work. Abi?
There's no example concerning that on the slide.
I will give you example for everyone, Abi.
As in, so the type of ligand NOS belongs to.
This is your NO. NO is nitroxy. This is nitroxy. NO. NO. This is S.
Okay, they are two separate.
They are two separate. NO is nitroxy. Go on. There are a lot of ligands. There's no way I will give you everything. That is why you have to read. This one now, what do you call this one?
Scandium.
SCN. What kind of ligand is this?
Ambidentate.
Ambidentate ligand. What I posted, most of you have not even gone. I will stop posting on the LMS.
Please post. You are reading it to. That's ambidentate now, like you said.
Now, if it's coordinated, because from here now it's shown that it's coordinated using the S. So what is going to be the name of the ligand? Thiocyanate. If your N was here, what is going to be the name?
Iso.
So
it will be 90.
It should be ISO now. Hey.
Yes, ISO.
So this is your NO is nitroxyl. It's your nitroxyl. So what? This is your molybdenum. So okay, let me ask you for this one now. What is going to be the name of this complex? Can somebody name it for us? This is what?
Oxygen.
Oxygen. So it's oxo. So what it means is that this complex is going to be, it's an anionic complex, true or false?
Yes, true.
So it's going to be molybdate. This is molybdenum. So because it's an anionic complex, I'm not going to name it for you. I'm just giving you a clue. So it's going to, this is oxo. So you'll be able to know the oxidation state. This is already oxygen. This is -1 with 4. So this is because both of them are anionic complex. So because both of them are anionic, so this complex automatically is an anionic complex. So it's going to be molybdate. So try and name the other complexes. So the other question says, write the formula of the following complexes. Sodium diaquabis oxalatorutenate 3. Ethylene diamine rhodium 3 chloride. Rutenate. That means it's an anionic complex. So it's ruthenium. Because oxalato is an anionic complex. Rutenate, that means, so please try it on, and the next lecture we'll see. Yeah.
Concerning that number 2.
Yeah.
That number 2. Normally, if we have OCl, we will name it as our as oxochlorate. But in this case, we'll name it as tetrachloride.
Thank you.
I'm sorry. Tetrachloride, right? Okay.
It's going to be your tetrachloro now. It's O. Ionic ligand ends with O. Oxo, chloro, bromo. It's going to be tetrachloro.
Before the oxo now. But the further will come before the oxo.
Of course now, of course.
So it's tetrachloro,
oxo.
But it's going to be sodium first, though. It's going to be sodium first.
Yeah,
I hope you know.
sodium tetrachloro oxo molybdate.
Molybdate. What is the oxidation state of molybdenum then?
+2. No.
What is going to be the oxidation state of molybdenum then?
+4.
+4. plus 4 because this is 2, this
It
is
will-
4, this is 2.
plus 4.
Oxygen is
So it
so
will
minus
be plus
Minus
2
3.
plus x minus 2 minus 4. So it will be plus 4.
correct.
Because
Yeah.
No.
So try your hands on each of them and then let's see how it goes. So we see on Wednesday.
Thank you.
thank you, ma.
Okay, thank you, ma.
Okay.
Thank you, man.
Ma, the slide. Ma.
Hello. Yes,